Hello, I'm Snigdha. Today we are going to discuss about sockets in this presentation. In this presentation, we'll get to know about what is sockets, the uses of sockets, socket addresses, and the types of socket system calls and server client implementations. Let us know what are sockets. Socket acts as an endpoint in connection between client and server present in a network. Sockets allow communication between two different processes on the same or different machines used. It's considered as a way in which different computers communicate with each other using standard file descriptors. In this slide, we see the OSI socket model system. Here, socket acts as an interface between the transport layer and the application layer, that is the user process, both in client and the server. So from this we can infer that the socket acts as an interface that the OS provides to its networking subsystem. Let's see what are socket addresses. Socket address is a combination of IP address and the port number. The socket address defines a process uniquely. For example, here the IP address and port number are given, and the socket address is the combination of both this IP address and the port number. The widely used socket address domains are Unix domain and Internet domain. Unix domain contains two processes that share a common file system which communicate with each other, and the Internet domain contains two processes running on any two hosts of the Internet which communicate with each other. Many uses of sockets. Sockets are usually used in client-server applications for communication. Many of the application level protocols like FTP, SMTP make use of sockets to establish connection between client and the server and then for exchanging data between them. Types of sockets. There are stream sockets, datagram sockets, and raw sockets. So firstly, let us know what is a stream socket. A stream socket allows processes to communicate using TCP. A stream socket provides bidirectional, reliable, sequenced flow of data with no record boundaries. After the connection has been established, data can be read from and written to these sockets as a byte stream. Whereas in datagram sockets allow processes to use UDP to communicate. A datagram socket supports bidirectional flow of messages. A process on a datagram socket can receive messages in different order from the sending sequence and can receive duplicate messages as well. And so now raw sockets provide access to ICMP. These sockets are normally datagram oriented, though their exact characteristics are dependent on the interface provided by the protocol. Raw sockets are not for most of the applications. They are provided to support developing new communication protocols. Protocols used. They are socket, bind, listen, accept, connect, send to, and require from, and close or shut down. So let's see what are there. Socket function is used for creating a new socket. The bind function assigns a local protocol address to a socket. The listen function converts an unconnected socket into a passive socket, indicating that the kernel should accept incoming connection request directed to this socket. And accept function is called by a TCP server to return the next completed connection from the front of the completed connection queue. And connect function is used by a TCP client to establish a connection with the TCP server. And the send to function is used to send data over unconnected datagram sockets, and the require from or require function is used to receive data from unconnected datagram sockets, and the close or shutdown function is used to close the communication. System calls socket. It takes arguments such as the protocol family, the kind of socket needed, and the specific protocol type. This call returns a socket descriptor that can be used later in system calls or -1 if any error occurs. Bind. It takes arguments such as a socket descriptor written by the socket function and the address and its address length. This call returns 0 if it is successfully binds to the address, otherwise it returns -1 on error. It takes arguments such as a socket descriptor written by the socket function and the number of allowed connections, that is backlog. Connect. It takes arguments such as the socket descriptor and the destination address, that is the server address, and its address length. This call returns 0 if it successfully connects to the server and -1 if it is an error. It takes arguments such as the socket descriptor and client IP address and the address length. This call returns a non-negative descriptor on success and -1 if an error occurs. Close. The parameter here is socket descriptor. It returns 0 on success and -1 on error. See TCP server client implementation. Here we can see server and client. In TCP server, firstly, using create TCP socket. Using bind the socket to server address. Using listen, put the server socket in a passive mode where it waits for the client to approach the server to make a connection. Using accept, at this point connection is established between client and server and they are ready to transfer the data between them. And in TCP client, create TCP socket and then connect newly created client socket to server. UDP system calls bind, where the parameters are socket descriptor, socket address and the length. It returns 0 on successful binding and -1 on any error. Require from. The arguments are socket descriptor, buffer, size of buffer, flags, source address and its size. It returns number of bytes read into the buffer or -1 on error. It takes arguments such as socket descriptor, buffer, size of buffer, flags, the address of the destination and the size of that destination address. It returns number of bytes sent or -1 on any error. Close. The parameter it takes is the socket descriptor and it returns 0 on success and -1 on error. Let's see UDP server client implementation. See both UDP server and UDP client. Firstly, let's see about UDP server. Create UDP socket and then bind the socket to server address and wait until the datagram packet arrives from the client. Then process the datagram packet and send a reply to client. And in the UDP client, create UDP socket, send message to the server, wait until response from server is received and then process reply and go back to sending message to the server and then close socket descriptor and exit. Thank you.